Hey, it's Tony from Adafruit, and this is the second stream of the day. They said it couldn't be done, but 2 streams in one day, we can do it. So this is the fourth part in the SQLite sensor storage series, and I think this will wrap it up. I think 4 videos is a pretty good in-depth series on a topic. So if you go way back, and I'll put links down in the description below to the previous 3 videos that I've done on this series. The very first video, I wanted to look at how do you use a database to store sensor readings, like temperature, humidity sensor readings, things like that. We talked a little bit about like what a database is, how to use the SQL structured query language to create database tables and query them and things like that. We looked at SQLite, which is a special database that's made to run kind of locally against a single file. But I did kind of mention there are other database engines that are a little more advanced and made for things like running as a server so that you can have like a web application with lots and lots of users that are accessing it concurrently. It's optimized for those scenarios. Whereas SQLite is more optimized for like one user running a program that maybe needs to store some state and things like that. So we talked a little bit about that. Now in this video, I thought it would be interesting to just take a quick little peek at how we can take the code that we wrote in the last 3 videos and make it use a different database engine. So the first 3 videos, we used the SQLite database engine, but I thought it'd be cool, let's use a different one like MySQL or MySQL, which is a different database engine. It's more optimized for those kind of web server scenarios where you've got a lot of users concurrently accessing it. I wouldn't say it's necessarily better or worse than SQLite. Like they have 2 different kind of markets that they're looking at. I wouldn't even say markets, 2 different audiences in that case. SQLite is simple and easy and just lives in a file, whereas MySQL is a server. It's a little more complex. It's got to be configured, but it's optimized for things like lots of users accessing the database at once. It can keep up with high levels of concurrency like that and scale out to be maybe more performant. So I thought it'd be interesting. We could see, it sounds like it could be this crazy thing like, oh man, we're changing the database, like we got to throw all the code out and start over. You'll actually see it is very easy to switch the database engine because we've written the app. And if you go back to like the second and the third videos, we used the ORM, the Object Relational Mapper, the Pi ORM specifically for Python. Because I'm using that abstraction on top of my database, you'll see how it actually simplifies changing the database. Like my code has no idea that it's talking to MySQL or SQLite or whatever database engine we want. And so we'll see how easy it is to do this. So let's see, let's just kind of dive in. I'll switch to the main view here. And okay, there we go. So like I said, MySQL or MySQL is what I'm going to use to do this video. So we'll use this as our database engine. And this is a link to it. It's open source, super popular. It's probably powering, I don't know, I would guess at least like maybe 40 or 50% of the web pages out there these days, as far as web pages with databases behind them. It's pretty much battle tested. It's been around for a long time. It has some known issues, like there is no perfect database engine. Everyone has different needs. MySQL is optimized for certain things that maybe other databases aren't. So, I'm not going to say like always use this. And I should also say that I am not an expert on MySQL. I know enough to be dangerous with it. Like if you're doing something production, get a real DBA to look at this and to set things up, because you can really shoot yourself in the foot, because this is a server, so it runs on the Raspberry Pi. Other programs can access it, like programs that you write yourself, or maybe some malicious thing that gets onto your network and scans and looks for databases and finds that, oh, you didn't configure it correctly and it's open to the world, and they can go party on your data. So again, be careful, learn a little bit about what you want to use and make sure that you're doing things securely, because in this series of videos I really haven't focused much on security. It's been more of just showing how to do some basic things. So maybe future videos I'd like to come back to that. But anyway, so this is MySQL. It's open source, so you can use it. It's super easy to install it. So let's just kind of dive into the Raspberry Pi. I'm connected with SSH to my Raspberry Pi right here, and I'll show you how to install MySQL, because the first step is we need to install the database engine. Luckily, it's super easy. So the first thing you want to do is sudo apt-get update. I'm not going to run this because it takes a little bit of time. That's just going to make sure your packages are up to date. and then sudo apt-get install mysql-server. And that's going to install the MySQL engine, just using the default one that the Debian OS or Raspbian OS uses, which looks like it's version 5.5, which is pretty recent. Now this didn't do anything for me because I've already installed it. When you run this the first time, it's actually going to pop up a dialog that asks you to set a root user password. And so remember, this thing runs as a server. It has its own concept of users who have access to the database, and you can get really fine-grained. You can say like, you know, I have a user for my application that can only access this database or these tables, or maybe it can only write data to this table and it can, you know, read data from another table. So I'm not going to get into all that, but it's just something to be aware of that you can get really advanced. You probably do want to set a root user password though, just because that's a pretty basic security thing. So I set a password on this as Raspberry, you know, hey, whatever, it's just simple. Now after you install this package, just like SQLite, remember how we had the SQLite 3 command, and this opens up a little terminal where you can start running SQL commands. There's also a terminal for MySQL or MySQL, so you can just run MySQL. And then you also probably want to specify a user, because if you don't do this, it's going to try to log into the database as the Raspberry Pi user, which hasn't been added yet. So do -u root, that says login as the root user. And then do -p, this will ask it to prompt you for your password. And so it's asking for the password. I'm just going to put in Raspberry right here. And you get a prompt that's pretty similar to SQLite. So, you know, you can run help to see some of the different commands that they have here. You know, things like you can, I don't know, connect to a different server, stuff like that. Now, the one thing is that, you know, MySQL, it runs as a server, so I'm not pointing this at a database file like I did with SQLite. You remember, there's the dht.db file that we created, and all of the database lived only in that file. Whereas with MySQL, it's a lot more advanced, and so it's taking care of where it stores the databases. I think they're stored, I don't know, probably under like /var /opt or who knows where they put it. It's somewhere on the Raspberry Pi, but it's not up to me because MySQL knows how to store the data. Like, it might keep some of it in memory, and if I'm not using certain databases, maybe it puts them out to disk. So I let it take care of all that because it's going to do whatever's most efficient for it. So it's just something to be aware of, that you can't just send your MySQL database to someone by copying a file. I mean, I'm sure there ultimately are some files you can move around, but that's not how it's meant to work. You know, if you want that type of scenario, you really want a database like SQLite that embeds itself into a single file. Okay, so I have this console open, and the first thing is it needs to connect to a database. So you can create multiple databases. You know, just think of a database as a collection of tables that are all under the same name database. So, you know, you could have like a test database with some tables in there, and then maybe a production database, you know, or a staging database, something like that. And the way you create a database in MySQL, you use the create database command and you just give it a name. So I can say like test, and you have to end with a semicolon because this is kind of SQL syntax, although I don't think create database is a SQL command. So this created a database called test, and then you have to tell it that you want to use that database. So that just means that now whenever I run SQL queries, it's going to be against this database. And this database has no tables inside of it right now. So I probably want to create a table, you know, foo, and let's give it, you know, how about an ID that's an integer and a name that's a varchar 50 or something like that. I think that's the right syntax. We'll see if that works. Okay, so that worked. And so now I can run like select star from foo, and it's going to show me there's nothing in foo, that table. So hey, let's insert into foo values, and let's say 1 and hello, something like that. Oh, semicolon, got to end it with that. And now I run select star, and hey, look at that, there's my row. So it's just like any other database engine. That's the powerful thing. If you learn the SQL structured query language, then you can talk to pretty much any database. Now, there's a lot of specific things that each database does, and some databases support more functionality than others, but the basics of like creating tables, inserting data, querying tables, it's all the same. It uses the same syntax. So that's cool, and that, you know, you write your program And you could just use raw SQL commands, and for the most part, it's not going to be hard to move between different databases as long as they all support the same commands that you're using. But then, remember, we use that ORM, that object relational mapper layer, in between the database and our application code. And so that is actually another level of abstraction where it can know, okay, I'm talking to the MySQL database, so maybe I need to tweak my queries a little bit or use some special MySQL specific commands that might optimize things a little more. So it's nice that you get some of that functionality just by using some of those abstractions. So, okay, so I created a test database. Let's create another database though. Let's create a database called DHT. And this will just be the database I'm going to use to store our DHT configuration, like the sensors and the sensor readings, just like the SQLite database that we created. But this time I have to tell the server to create this database. And it's not something that I noticed the Pi ORM will create automatically. Like maybe there's a command, I didn't really look for it, but I think it's probably easiest, when you're creating the database, you probably want to log in and explicitly do it as like a provisioning step here. So that's all that I need to do. At this point, I can just quit out of here. So it's quit semicolon is the syntax that they want. And we should be okay. So remember, like this thing, it's on the MySQL server. There's no file here. If I look in this directory, well, I do have a dht.db. That's just because I copied this from part 3. So I don't actually need that thing. It doesn't have anything in there. But again, it's the same files. And so I just copied over all the files from part 3 and I just stuck them in a part 4 directory. So we're just going to work off of this and modify it. Okay, so I've got MySQL installed. There's one other little thing that I need to install. This is a Python library that lets Python talk to MySQL. And so I want to run sudo pip3 install Pi Mysql. And I've actually already done this, it's already installed, but you want to install this because now the Pi ORM can use this Pi MySQL package to talk to my MySQL database that we just created here. So one little kind of setup step there, and then we're good. Okay, so now at this point then, I'm going to switch to, this is the documentation for Pi ORM. And they kind of mention like, if you want to use different databases, so remember, like we looked at using SQLite and it was as easy as just doing this, creating this SQLite database and then pointing it at the file that we want to use. So for MySQL, they have a MySQL database class and you give it the name of the database. And then they don't mention it here, but it's in their example apps. Unfortunately, it's really not mentioned at all in the documentation. If you have a username and a password, you can specify those as extra parameters to the initializer for this database object, and I'll show you how to do that. But that's the only change that you really need. Like your model doesn't change at all. You're still creating like car fields, integer fields, everything's the same. Behind the scenes, Pi ORM will go back and say, okay, you're using the MySQL database, and I know, a character field must map to a varchar in MySQL, whereas in SQLite, maybe it maps to a text field. I don't have to know or care about that kind of mapping. It's done for me by the object relational mapper, which is great. It simplifies my code. It makes it a little more portable in the sense that, as you're noticing here, so I'm going to just change this one line. And that's honestly the only bit of coding that we need to do in this entire stream to make this work. So I'm going to change this from SQLite database to MySQL database. Now I need to give the name of my database. This is the one that I ran that create database command for. This check same thread thing doesn't matter anymore because remember, this was back in the previous example. I needed this for SQLite because I needed to tell SQLite that, hey, I might have multiple threads or multiple users accessing this database at once, so be careful about how you do transactions and things. Whereas MySQL, it was built from the start to support multiple users with concurrent access, so it just inherently supports that. I don't need to put it into some special mode for that. But I do need to tell it, if I remember correctly, it's a username. I think it is. Let me just cheat real fast and make sure that I get the right thing. So I did the code ahead of time here. So, it's user and then pass WD is what we want to use for this. So user equals, and then give the username. So in this case, it's root. That's the user that was created for my database. And then the password, so pass WD, and we'll say raspberry. Now, be careful. Don't put passwords for production systems in your code, and don't check that code into GitHub, because you can delete the file, but the record is still there and you've got to wipe out the whole repo to get rid of it. So word to the wise, like this is fine for testing. I almost feel bad showing people like to do this, but you know, look into different ways of storing credentials. Like you could maybe store it in an environment variable and then use the Python, I think it's the environment class, or for sure it's in the sys class. You can read environment variables. That's a smart way to do it, because that way, you know, you can set that environment variable and you could put that into, you know, maybe a script that runs your script. And so only that knows your password. You know, there are lots of different ways to deal with this. Maybe a future video I should look into this, because every time I talk about security, I'm like, oh, we'll do it in a future video. So at some point I should come back and do that. But just be aware, like this is not secure. This is not recommended for production stuff. But for you on your Raspberry Pi, hacking on some code, it's probably okay for this. So, okay, so I'm going to save this. And I'm not making any other changes. So the model is exactly the same. You know, this defines a sensor, which is going to turn into a table that's going to have, you know, character field, integer field, that type of stuff. Nothing else changes. So I'm going to save that. And then let's run our web application for this. So let's see, we'll go back to the Pi. And so remember, I had that webapp.py. And this is a little Flask application. It uses the Flask admin system to automatically generate web pages. And then we saw in the last video how I built a little graph that shows the sensor readings here. Okay, so let's run, and the way you run this Flask app, you have to set the Flask app environment variable to the name of the file, webapp.py, and then you run the Flask command, and then you give it the run sub command, and then you give it the host that you want it to serve this on, which is local, well, not localhost, to listen on any host. A little verbose. I wish Flask would have like a test server or something command that just automatically did this. Anyway, so this is the new way to run Flask applications. So we run this, and now it's running my web app, and if I access Raspberry Pi port 5000, it's going to spin for a little while, and hey, it popped up. And, you know, I don't see any graphs here because there's nothing in my database. So I can go to, like, you know, here's my DHT sensor table, and there's nothing in here yet. But I can create stuff just using, you know, this Flask admin GUI, which it's really nice. And as we saw in the last video, it was like almost maybe 2 lines of code to get this whole interface built for me automatically. Okay, so let's call this DHT1 because I have 2 sensors connected to my Pi. This is my Pi over here. Nothing's changed. I still have 2 sensors, one on pin 18 and one on pin 23. So I have a DHT22 on pin 18, and I'll save that. And then I have another one. I have we'll call this DHT2, and this is a DHT type 22 sensor on pin 23, I believe. Let me check. 25. See, I'm glad I checked. So 25. So there we go. So we'll save that. So cool. So I've added a couple rows. Now, before we get too far into this, I'm going to go back to my Raspberry Pi. This is the Pi again that I'm connected to. Let's go look at our table real quick. So let's run MySQL user root prompt for the password. And let's use database, or just use DHT. Okay, sure. I've never seen that before, but okay, that sounds cool. Reading table information. Oh, that's interesting. I guess if I press tab, then it must know which tables that I have. Oh, that's kind of cool. All right, so let's do select star from, what if I hit tab? Oh, maybe we don't want to see 700 tables. All right, so if I remember correctly, PWORM creates a table called DHT sensors. So, and I think it's all lowercase. So if I do DHT, does it give me an option here if I hit tab? Oh, I think it does. Yeah, so it does tell me these are all the DHT things. So, okay, that's kind of cool. All right, so select star from DHT sensor. So, hey, look at that. These are the 2 rows that I just added right there. So you can see ID1, name DHT1, type 22 on pin 18. Same thing for this sensor here, but just on a different pin there. So it's cool. Like, we're really using this database here. We're not using like the SQLite database anymore. And it was really just this one line that I changed. And I fired up the web application. You know, I didn't even change the webapp.py code at all. You know, it's using this model file right here that's using this changed database line. So that's cool. That's pretty powerful that I can just swap database engines without a ton of work here. Okay, so now I've got my 2 sensors defined. And if I go back here, so it knows these two sensors, but I don't have any readings yet. And that's because I need to use that dht-read.py script. And so let's grab that one real quick. So dht-read.py. Now I'm going to change this. I'm actually going to comment out these two lines, because these two lines just check to make sure I have a DHT1 sensor and a DHT2 sensor in my database, and if I don't have them, it'll automatically create them. But because I've got this whole little GUI now to add my sensors, I don't really need this in the code anymore. So I'm just going to comment them out. But then the main loop is just going to read which sensors I have defined and start grabbing sensor readings for them and then writing them back to the database. So let's run this script. Let's go to my part4 directory in here, and then let's run sudo python3 dht-read.py. And remember, I really haven't changed anything in this file. And hey, look at this. It's grabbing a couple sensor readings. I'm going to blow on one of the sensors right here. So this one. And this will increase the humidity of this one. It's DHT1 that I just blew on. So I should see in the next reading it's going to jump up to a pretty high value. So we give us, yep, see 93% humidity, so that's a pretty large value. Now while this is running, I'm going to go back to my web page here, and let's go back to our home, and hey, look at this. Here's our sensor readings here. So, you know, here's DHT1, it started out around 60%, and then it just jumped up to 90%. Whereas sensor 2 is, you know, around 60% or so, kind of the baseline humidity in the room. And remember, this isn't a dynamic page, so I have to refresh it. But if I refresh it, you can see now it's grabbing the latest sensor readings from here. And I can go back and also see, so, you know, that sensor is still around 99% humidity in here. So pretty cool. And I can go back now, I can start looking at my sensor readings. These are all inside of the MySQL database. So I can see, you know, hey, I've got a bunch of rows inside of here. And if I really want to see them, you know, I can go back and I can open a new terminal. Let's connect to my Pi. And let's just look at our table again. So if I run MySQL, user root, prompt for password, and then use DHT database, and then select, I think, let's see if MySQL has this top 10 star. This might be a Microsoft SQL only thing. I use it all the time though when I was using Microsoft SQL. All right, select top 10 star from sensor reading, I believe is the name of the table. Okay, so I probably can't use this top 10 thing. So, okay, let's just do select star. Okay, so hey, look at that, 87 rows. It just grabbed back a bunch of these. And remember, you know, I can do more filtering. Like if I want to say where, I can't remember the name of the columns here. So yeah, where name is like, how about humidity? So this will grab all of the humidity measurements from any of the sensors in here. Oops, I have to do semicolon at the end. And hey, 54 rows, and notice these are all humidity sensor readings. So like DHT1 humidity, DHT2 humidity. So again, all that data is in the MySQL database. And it was really as easy as just, oops, didn't want to do that. I wanted to do quit. There we go. It was as easy as changing that one line in the model here. So that's kind of the power, like what I wanted to get across of using something like an ORM, an object relational mapper. You know, my code in the very first video, I wrote code that just had raw SQL queries. And those are actually still pretty portable. You know, the SQL language is standardized, and if you're just doing like basic table creation and stuff like that, it's probably going to work across a bunch of database engines. But then we saw using this ORM layer, you know, this abstracts away the database. So I'm not writing SQL queries anymore. I'm defining my tables as classes, you know, with different attributes that map to columns in that table, and then instances of this class are rows from that table. And the Pi ORM has all of this query functionality, and so I made this little data access class that has, you know, higher level functions like get all of the recent readings, which just turns into a select query against my sensor readings with some filtering and ordering and limits and stuff like that. But it's, you know, it's all abstracted away. Like my code here has no idea that it's talking to the MySQL database engine. It's only this line that tells it that. And if I wanted to switch it back to SQLite, you know, it's as easy as switching this line back for that. So that's kind of what I wanted to show. So it's, you know, just a quick little hint or taste of what you could do if you build your database code using these abstractions. It's in some ways I wouldn't say it's like always the right choice. By using an abstraction like this, you lose a little bit. Like you don't have direct access to the database, and so if MySQL has some like special optimizations or things you want to use, you might not get that functionality. Now with PWORM, you actually can, I believe, run like raw queries against the database and let it do whatever. But at that point, it's like, well, why are you really using the ORM if you're just going to run the raw queries? Maybe you need to at some points. So just be aware of that. There are trade-offs to everything, but this is pretty powerful, and that it's easy to switch to using a different database engine. And then you might wonder, like, okay, well, why would I want to use MySQL? And I don't have a good example of that here, but like I said, so MySQL and just all database engines in general, it's all trade-offs. Like there's no perfect engine that's going to work perfectly for every scenario, for every person. MySQL is maybe more optimized for like web scenarios where you have lots of users accessing maybe a relatively simple database. Whereas if you have a really complex data model with lots of different related tables, then maybe MySQL isn't the best option there. Maybe different database engines are better. Or if you just want a small portable database that only one user is going to use, SQLite, that is exactly what it was designed for. There's no need for the complexity of installing a whole database server because, at this point, remember, my Raspberry Pi is running MySQL. It's just using whatever the defaults are that the Debian package has. So as you notice, like it has a root user. And if I was a hacker, and I started looking at someone's network and I realized that they're running MySQL, I'd probably try to log in with the root user because 9 times out of 10, they haven't changed that user, and it's maybe even has no password set for it. So, be careful. You need to realize that you're running a server, and if it is something you're going to use in a production environment, go figure out how to harden it before you even start writing your application code, because you don't want to push this thing out and then have it get taken over. So I think that's it. I guess if folks have questions, throw them into the chat. It's kind of a quick one, but it's still kind of useful info. I just wanted to maybe wrap up this series by showing that you can just use an abstraction layer on top of your database and very easily change things around. Another scenario that would be like maybe you start building your application using SQLite just as a local database, and then you want to start expanding it out and letting like multiple users access your web page. So at that point, then maybe you want to switch to using like MySQL or a different database engine for this. So cool. Okay, so let's see. I don't see a lot of questions. Let me switch to the main kind of headshot here. There we go. Okay, cool. But let's see. People are mentioning, we should have an on-air sign. We do have an on-air sign, actually. I think if you go back, there was a Desk of Lady Ada build where Noah and Pedro for sure had a project on an on-air sign using the ESP8266, if I remember correctly. And I do actually, that reminds me, I want to do a live stream in the future to come back and check out MicroPython on the ESP8266, because I think they've added like MQTT support and stuff recently. Like that project is just on a roll. They are adding all kinds of new stuff. And if I remember correctly, they've got NeoPixel support and some basic web app support. I think we could build the on-air sign entirely in MicroPython on the ESP8266. So it might be a future stream that I'll think about for this. Otherwise I'll wrap it up then. So this was, the last part in the SQLite sensor storage. So really kind of like intro to database. Like I said, I didn't get super advanced. I didn't even mention foreign keys and how tables can be related, mostly because I just wanted to get across the point that databases don't have to be these scary things. Because I know for sure, before I really like understood and used databases, I always thought like, oh boy, databases, that's just a whole area of programming and that I have no idea about, and I'm not going to use it because I don't understand it. But at the end of the day, and if you go back to the first video, the database is really similar to a spreadsheet. You have a concept of a table that has columns and rows of data. Each row has something for those columns, or sometimes it's null. Maybe there's nothing in there. And so if you want to store a bunch of sensor readings, like, a list of every second readings from a sensor, a database is a great place to do that. And as we saw, like, you know, if you put it in a database, then it's easy to query that data. You can use the structured query language, which is a very powerful language. You know, you can do all kinds of advanced queries. Like if you want to filter to specific rows of data during a period of time that match some constraint, easy to do that with SQL. You know, you just write a query. Whereas if you're using like a spreadsheet, you've got to figure out how to use all these GUI tools. And every time I use a spreadsheet, as soon as it gets so complex, I start to realize, like, you know, I should have just put this in a database where I can just write a SQL query, because that's how my mind thinks about this stuff. So that's what I wanted to get across here, is that, you know, look at a database as a good way to store data. And as I also showed in the series, I'm also storing program state. So, you know, this DHT sensor table that I have here, this is the list of sensors connected to my Raspberry Pi. And in the previous video, in the third video, I showed how I can dynamically change this. If I add a new sensor to my Pi, I just need to add a new row to this database table. Oops, I realize I'm not showing this on the screen, so let me switch back to this. So yeah, remember, you know, this DHT sensor table here, if I just want to add a new sensor, I just have to create a row, and I've got a whole little GUI to do that. Whereas if I wanted to do this without using a database, like, I'd need to code my app in some way that it looks at some central spot for its configuration, and then maybe it like periodically queries that, and that starts to get really complex. I mean, at that point, you're kind of writing your own like basic in-memory database thing. So, you know, the database is there for a reason. It can store data. There are lots of different ways to model data and make it into a representation that a database can store. And as you saw, using something like an ORM, object relational mapper, like that Pi ORM, it doesn't have to be that hard. Like, it's as easy as defining a class in Python and, you know, just defining certain attributes, and that's easy enough for this system to take it, create your databases, create your queries and all of that automatically, populate your tables, that type of stuff. So, okay, so that's it then. I'll wrap it up. Thanks a lot for watching. Subscribe to youtube.com/Adafruit. You can watch this video and all kinds of other fun videos and projects. Twitch.tv/Adafruit. That's where I live stream this. I do a couple live streams every week. On Mondays, I like to do a quick look at interesting Raspberry Pi software. I just saw a neat thing. Man, I can't remember the name of it. I guess we'll find out Monday what it was, but it looked like an easy way to configure your Raspberry Pi wireless access. Like if you wanted to make your Raspberry Pi a wireless access point or to connect to a Wi-Fi network. I looked at something a while back, which I'm blanking on the name on. It was created by the creator of Octoprint and Octopi. And so that was, I think, NetConnect D was what it was called. So that was a system where it's like you put it on your Pi, and then your Pi boots up and it creates an access point that you can connect to and configure Wi-Fi. So this is another version of that, a different type, same idea, but it looks like a more GUI, more graphical version. Like it has a really nice looking web app. So I might look at that on Monday. But anyways, Mondays I do a quick look at Raspberry Pi software. Fridays I like to do more in-depth streams like this. So I just wrapped up the SQLite sensor storage one. So Friday next week I'll start some kind of a new series, and we'll see kind of what we can do going forward in the future. And then look during the week, I like to do some other stuff. Like actually earlier today I did a little Circuit Playground stream. So there's all kinds of cool live content. Desk of Lady Ada. Lady Ada shows off how she designs things and just talks about cool stuff. There's Ham Sunday, which I might be joining pretty soon. I got my tech license this week, so I also got my call sign, so I am KI7FKL, so I don't have a radio yet, so you might not hear me yet, so pretty soon. And then Noah and Pedro have Layer by Layer, all kinds of cool 3D printing stuff. I just saw too, they had an awesome video on how to register your drone with the FAA, which I thought was really cool, because it's like, this is this new thing we need to figure out how to, you know, use our drones in a good way. So it's neat to walk through the process and see how that works. So yeah, like, comment, subscribe, let us know that these are cool videos, that you're getting good stuff out of it, and we'll keep them coming. You know, your comments and things keep us going. So thanks a lot, everybody. I will see you guys on Monday then. So have a great weekend. This is Tony from Adafruit.